there's a maths equation that literally beats with your heart. And this is the equation. So your heart would beat like this, which you've probably seen. Which, in other words, is a wave. Now, if we had a graph here, it would kind of look like this, right? And this is also known as a sine wave, which is y equals sine of x, where x is on the x-axis and y is on the y-axis, like this. Good. And this would go between 1 and -1, and that's a sine graph. So you would need to know how to plot that in GCSE. Now, how could this be with your heart? What am I talking about? Well, if your heartbeat was at, say, for example, 70 beats per minute, well, therefore, the frequency, let's say, would be 70, right? So the frequency on a sine graph will actually be in here. I'm going to mark it as F. That's your frequency. And the amplitude will actually be on the outside here. So now we can actually know what a sine graph looks like. So, okay, say that someone's heartbeat has an amplitude of, I don't know, let's say 10 decibels. That's how loud it is on the y-axis. And it's a sine graph. And let's say that the frequency of it is, 70 beats per minute. So we actually have a function now, which will be able to plot someone's heartbeat, which again, on the same graph, would look like this. Well, here's a normal sine graph. The frequency now is 70, so it would be a lot quicker, like this. And this would happen 70 times within one interval, which we'll call a minute, right? And the amplitude of it, although it looks small, this would be 10 decibels, right? And you might be keen to think that, well, you can't get negative decibels, which is true. So essentially, this part of it wouldn't be looked at. But in other words, in maths, you can model, in terms of a function, the frequency of waves, a heartbeat, or even the moon revolving around the Earth. So this is a really, really powerful trick, and it's good to know where you put coefficients in front of a sine function and what they do.